Hello, my dear students. In this video module, I am going to discuss the basics of probability. So let's get started. First thing which I am going to discuss with you all is what is meant by a sample space. Consider that I am performing an experiment, say rolling a dice. Okay, so I'm taking a dice, it's a fair dice, and I am rolling it. The set of all possible outcomes when I am rolling a fair dice, it's that I may end up seeing the number 1 or 2 or 3 or 4 or 5 or 6, right? So this is what I call it as the sample space, the set of all possible outcomes when I am performing an experiment. That is called as the sample space. The number of elements in this sample space, you can see that it is equal to 6 in this experiment. Consider another experiment. Say I am tossing a coin. So when I am tossing a coin, I end up seeing either heads or tails, right? So that is the sample space in this case. Number of elements in this sample space when I am performing the experiment of tossing a coin, the number of elements in the sample space, it is equal to 2. So I believe that you got the idea what is this sample space it's all about. Now, after talking to you about sample space, I'm now going to talk about something called as an event. Let us consider an event here. When I am rolling a dice, I end up seeing a composite number. Okay, so the experiment is rolling a dice. So you know the sample space is 1, 2, 3, 4, 5, 6. And the event I am defining here, it is me seeing a composite number. So I can say if I see the number 4 or if I see the number 6, then I have satisfied the condition, that is seeing a composite number. So the event I am defining is seeing a composite number. Number of elements, the favorable elements in that event E, as per the sample space I have defined here, the number of favorable outcome that I can see here, it is equal to 2. All right. Now, let me say I end up seeing prime number. That's the event I am defining. Okay. That is when I am rolling a fair dice, I end up seeing a prime number. Okay. So if I see the number 2 or 3 or 5, then please understand the condition that I have defined here, seeing a prime number, I have satisfied that. So the number of favorable outcome in this case, that is equal to 3. Okay. So you should be knowing what is this event it's all about. Let me define another event here. I am rolling a dice and the event I am defining is seeing the letter, say, A. So can you tell me what is the favorable outcome here in this case? I am rolling a dice and I am defining an event that I end up seeing the letter A. So I will say that this particular event, when I am rolling a dice, seeing the letter A, I say that it is an impossible event. Okay, because it's never going to happen. In the same way, let us consider the case that I am tossing a coin. Okay, so let us consider a particular experiment wherein I am tossing a coin. Okay, now I am defining an event, that is, I end up seeing heads and tails. Okay, please note, I am using the word and here. I end up seeing heads and tails. Okay, so when I am tossing a coin, will I see heads and tails at the same time? No, right? So seeing heads and tails again, it is an impossible event. Okay, it's an impossible event. So you should be knowing what is the event, and also you should be knowing what is this impossible event aspect also. Okay, so with the help of these concepts, let me now define the concept of this probability. Probability, it basically tries to quantify the chance of occurrence of an event. Like I explained earlier, when I roll a dice, the possible outcome, it is 1, 2, 3, 4, 5, 6. So the total number of outcome in this case, when I am performing that experiment, it is equal to 6. Now, I am defining the event, I end up seeing a composite number. So if I see the number 4 or if I see the number 6, I have satisfied the condition. So the number of favorable outcome, that is equal to 2, right? So probability of that event E, it is nothing but 2 by 6, which is equal to 1 by 3. That I end up seeing a composite number, right? So I can now say and define probability for a particular event E. It is as such, it is quantifying the chance of occurrence of that event E. So probability of an event E, if I want to calculate in the denominator, I should consider the number of outcomes. Okay. I can even say total number of outcomes. I'm just writing it as number of outcomes. And in the numerator, I should consider number of favorable outcomes. Okay. So probability, that is the chance of occurrence of an event, it is number of favorable outcomes divided by total number of outcomes. Okay. So this formula you will be using left, right, center for solving questions based on probability. Okay, now let me talk about something called as odds in favor or odds against an event. Okay, so probability that an event E happens, it is P of E. Probability that the event does not happen, I represent it as P of E bar. P of E bar will be 1 minus P of E. So this is the first thing which you have to keep in mind. P of E bar is 1 minus P of E. Probability for an event which is impossible, P of E, an impossible event, the probability it is 0. Okay, so this is the case associated with impossible event. Okay, for example, I mentioned when I am rolling a dice, what is the probability that I end up seeing the letter A? It's an impossible event. So P of E will be 0 in that case. Okay. In the same way, if an event is certain, it is definitely going to happen. Okay. For example, when I am rolling a dice, what is the probability that I see a 1 or a 2 or a 3 or a 4 or a 5 or a 6? I will say that the probability of that defined event, it is equal to 1. And if that is the case, I will say it is a certain event. Okay, because that is definitely going to happen. So I can see that probability associated with a particular event, it will always lie within this range of values. It will be always between 0 to 1. It can neither go negative, it can nor go more than 1. So if I am considering a number line, probability for a particular event, it will always lie within this range. If I am writing it in terms of interval, it will be always lie between 0 to 1, and 0 is also a possibility, 1 is also a possibility. So it will always lie within this range, all right, between 0 to 1. Please keep this in mind. Now, after defining this much, let me now talk about odds in favor of a particular event. So odds in favor of an event, let me say it is A is to B. It means probability that the event E will happen it is A divided by A plus B. The probability that the event E, it will not happen, that will be B divided by A plus B. Okay. Now, odds in favor of a particular event is as such probability that the event E happens divided by probability that the event E, it does not happen. So this is what P of E by P of E bar. This is what odds in favor of a particular event or for a particular event. Okay. Now, in the same logic, let us talk about odds against an event. Odds against an event, let me say it is P is to Q. If that is the case, probability that the event E, it does not happen, that will be P divided by P plus Q. And the probability that the event E happens, that will be Q divided by P plus Q. So, odds against an event, it is basically probability that the event E, it does not happen divided by probability that the event E, it happens. So this is what odds against an event, it actually represents. Based on this concepts on odds in favor and odds against, I have set a couple of questions for you. So you should be knowing how to interpret that A is to B and that P is to Q that I have just defined. So use it properly. Okay. Now, we all are familiar with one particular, I should say, an equation, N of A union B, it is equal to N of A plus N of B minus N of A intersection B, right? We are familiar with this particular equation that is coming in set theory. So imagine I'm going to replace that N here with P. Okay, look at this. So then I can say it looks like P of A union B is P of A plus P of B minus P of A intersection B. It means probability that the event A or B, it happens. Please note, union logic, it corresponds to or. Intersection logic, it corresponds to and. Okay, so I can say probability that A or B happens, it is equal to probability that A happens plus probability that B happens minus probability that A and B it happens. All right. Now, what is so special about P of A intersection B? Please note, P of A intersection B, I have to deal it in two different cases. Okay. If I consider that this A and B, okay, A and B, if I say that they are mutually exclusive, okay, mutually exclusive. If this A and B that I am defining, they are mutually exclusive, then P of A intersection B, it will be equal to 0. Now, let me explain what is mutually exclusive. Mutually exclusive means happening of A will suppress, prevent the happening of B. Happening of B will prevent the happening of A. Example, tossing a coin. When I am tossing a coin, if it is heads, you definitely know that it is not tails. Tails is not going to happen. In the same way, if it is tails, you know that it's not heads. Heads, it's not going to happen. Got it? So what is the probability that when you toss a coin, you end up seeing heads and tails like we defined? Probability that it's going to be heads and tails, it will be equal to 0. Okay, so that is the reason why when the events are mutually exclusive, P of A intersection B, it is equal to 0. Probability that A and B happens, it will be equal to 0. Now, let us talk about the next scenario wherein A and B. Okay, let me say A and B, they are independent, okay, independent events. Okay, so if I say and define that A and B are independent events, which means happening of A is not going to affect happening of B and vice versa. If that is the case, P of A intersection B, that is probability that A and B it happens, that will be P of A into P of B. All right. And one more thing which I would like to add here. If you remember in the fundamental principle of counting, when it comes about OR logic, you add that, right? A or B. When it comes, you add P of A plus P of B. Since a double addition is coming, you are subtracting minus P of A intersection B. But anyway, union, that is OR logic, it is associated with addition. And see this AND logic, fundamental principle of counting, when it is AND logic, you remember it corresponds to multiplication. P of A intersection B, it is equal to P of A multiplied with P of B. And comes, you go ahead with multiplication. So fundamental principle of counting, addition and multiplication, it is actually applicable here. Okay. So with this quick introduction, now I have shared with you the basic equations and the concepts which you should be familiar with before you are solving the questions presented in front of you. Thanks for watching. Best wishes.